In this video, we're going to start subsection 2.2.3, the interpretation of the derivative of a vector function as the tangent vector. So the graphical interpretation of the derivative of a vector-valued function is related to, but it's not quite the same thing as the graphical interpretation of a real-valued function that you'd be used to from your calculus course. So if we remember what r prime of t was defined as, it was the limit as h goes to 0 of r of t plus h minus r of t over h. So if we imagine that our vector function is in 2 dimensions, and so we've got a curve here in R2. If we want to interpret this graphically, let's put these things up on the curve. So if we have, let's imagine the position vector or the radial vector at some point t0. If in our example we take h as greater than 0, and if we imagine that the curve is got a direction or has got a direction as I've just shown here, then if we look at t0 plus h, we are going to be further down in the direction of the curve. So this might be the radial vector at r of t plus some amount h. So what then is this subtraction? R of t0 plus h minus r of t0. So you should remember, hopefully from your vectors unit in your linear algebra course, that that subtraction can be drawn on the graph right there as completing a tip-to-tail rule. So this vector that I've drawn in green is r of t0 plus h minus r of t0. It's a secant vector. And if we imagine then that as h goes to 0, from the right, since our h is positive, then that secant vector is going to, let me just duplicate it here, that secant vector is going to move along the curve back towards the initial point. And if we take, let's draw this maybe fully here in red, if we take this vector and we imagine it going back and following the curve all the way back to that sort of initial point, well, we end up with a vector that is on the initial point and in the direction, it's hard to get my animation, there we go, in the direction of the curve. So obviously if h were to reach 0, well, we'd end up by dividing by 0, which we cannot do, but we're talking about the limit as h goes to 0, and so the limit of these secant vectors turns out to be this tangent vector. So this is r prime at t0. So if we read the following definition, the tangent vector to the graph of a vector function r is t of t, capital T of t, which is defined to be r prime of t. So we call our tangent vector t, t for tangent. And if the length of the derivative vector is not 0, well, then we can divide by it and we can come with the unit tangent vector. So that's 1 over the length of r prime of t times r prime of t, right? Which you should remember from your vectors unit again, that dividing a vector by its non-zero length gives us a unit vector. And the last little definition, the graph of r of t is called smooth also if that derivative is not equal, the length of that derivative vector is not equal to 0. In the next video, we'll do a little example that will apply some of these concepts.